Okay, so concept C, similar triangles and slope. And we're going to jump to the example. Explain that the slope is the same between any two distinct points on a non-vertical line. Alright. The following line passes through the points A, -2, 4, B, -1, 1, C, 0, -2, and D, 1, -5. Alright, so they have them plotted out, which is lovely. I love the graphical representation of it. Okay, Tanja and Manfred compare the slope between points A and D with the slope between the points B and C. They begin by drawing two right triangles, triangle ADF and triangle BCE, where triangle ADF has a right angle at the point F at -2, -5, and triangle BCE has a right angle at the point E. Coordinates are 0, 1. Okay. So here are my triangles with this long line and this little triangle. Okay, so Tanja claims that triangle ADF is not similar, so that symbol is read as not similar, to triangle BCE. So the slope between points A and D cannot be shown to be the same as the slope between the points C and D using similar triangles. Manfred claims that triangle ADF is similar, that's what this symbol is, similar to triangle CBE. However, the rise is negative from point A to point D, and the rise is positive from point C to point B, so the slope between points A and D cannot be shown to be the same as the slope between points C and D using similar triangles. Which answer choice correctly analyzed the students' claims? Okay, so let's talk about Tanja's claim before we read these choices. Alright, Tanja claims that the slope between the points A and D cannot be shown to be the same as the slope between points C and D. I just want to think about that for a second. Slope means the rate of change. So if the rate of change, or how steep it is not the same, I would have a line that would change steepness. Either it would have to become more steep or less steep between points B and C in order for it not to have this, in order for it not to be on this same line, in order for it not to have the same slope, which is obviously false because all four of these points are on that line. Okay, so let's look at Manfred's claim. So the slope between points A and D, point A and D is the rise is negative, so it went down. That's what it's saying. The rise went down is negative, and the points from C to B, she's saying that I had to count up and the rise is positive. which is correct if you are going from C to B. When we read a graph, we read it left to right, or because that is how the x values increase. So we're reading a graph from left to right to see that the x values increase. So if I'm looking at this from A to B, A to D, it was already being read from left to right because the x value at A is -2 and the x value at D is 1. So that's being read left to right. And she is correct. The rise did technically go down. So if we read the graph correctly, we would be going from point B to point C from left to right because point B has the x value at -1 and point C has an x value of 0. And if we were to look at it that way, starting from point B because it's the smallest x value, -1, to point C, the rise would have to go down as well in order to get to point C. Oh, hey, I just learned something nifty. Okay, so after we just talked about that, let's read these analysis. So tangent is correct and Manfred is incorrect. The ratio of A to F to BE is not the same as the ratio of DF to CE. So triangle ADF is not similar to triangle BCE, and the two slopes cannot be shown to be equal using similar triangles. Okay, let's talk about this. She is saying the ratio of AF, so this side length, AF, to BE is not the same ratio as DF to CE. Okay, well, my first problem with that statement is she's not comparing corresponding sides. So A to F should be compared to CE because they are both the vertical height of the triangle. It's their corresponding sides. Okay, so then let's read the next one. Manfred is correct and tangent is incorrect. Even though triangle ADF is similar to triangle CBE, the fact that one rises negative and the other rises positive means the two slopes cannot be shown to be equal using similar triangles. Okay, we had talked about that earlier. She was not reading the graph correctly from left to right. So, they still have a negative slope because they lie on a line that has a negative slope. So this point from B to C is going to have a negative slope. It is lying on a line that has a negative slope. Okay, so let's read the next one. Both tangent and Manfred are correct. The two slopes cannot be shown to be equal using similar triangles because triangle ADF is not similar to triangle CBE, and the rise using triangle ADF is negative, but the rise using triangle CBE is positive. So again, you read a graph left to right. And another thing that I am going to bring up is they're only talking about the rise. They're not comparing the whole slope. So if you said, okay, well, Mrs. Wood, your explanation of starting from A to D, I can see that, but they're talking about going from C to B, and that's the order that I want to go in. Okay, we'll talk about that. So if I go from A to D and I find the slope, so AD slope. So M is going to equal the rise of it. So I've got to go down. How much do I have to go down? 1, 2, 3, 4, 5, 6, 7, 8, 9. So down 9. So that means I have a negative 9 all over. This is the part they are forgetting. Slope is rise over run. So I've got to make it to the point D. 1, 2, 3. Okay, negative 9 over 3, that reduces to negative 3. So this slope from A to D is at a rate of negative 3. Okay, so then let's look at from C to B. I'm not going to use that. So CB slope. And I'm writing in an attempted cursive because it's easier to use than clicking it every time. So their slope, let's look at it. They're saying the rise from C to B is positive. I agree if you're looking at that direction. C to B. I'm going up according to this triangle. 1, 2, 3. I went up positive 3. This is the part that they are forgetting. Slope is rise over run. So how far did it have to run to get to point B? 1. And it had to go to the left. So that means it is a negative 1. So if we simplify 3 over negative 1, that equals negative 3. So yes, if you are looking at it from C to B, the argument of C rising being positive in order to get to B is correct. But the other half is the run is now negative. So that is still why we end up with a negative slope. You have to look at both parts of the slope in order to compare them. So this last one, neither Tangent nor Manfred are correct. The two slopes can be shown to be equal using similar triangles because triangle ADF is similar to triangle CBE, and the ratio of AF to FD is equal to the ratio of CE to EB. That is what we just talked about. So AF to FD. So the rise, AF, to the run, FD. That is the slope. The ratio of CE to EB, the rise, CE, to the run, EB. That is also the slope. We have to talk about both parts if we're using slope. So that one is what I agree with. All right, and then if you want to read that, that gives you another example or gives you another reason of why the triangles are similar.